is a logarithm? Well, basically the first thing you need to understand is the index notation. When we write indicial equations such as y equals a to the power of x, okay, we're going to call a our base. So let me just use a different color. A is the base, okay, and I'm gonna call y our base numeral, and x I'm gonna call that our power. Now notice how x is in the power position. So we have y equals a to the power of x. Now if I told you, for example, let's say y equals, hang on, let's just do another one. So a equals, let's say 3 to the power of 2 equals 9. Right, 9 equals 3 to the power of 2. Right, because 3 times 3 equals 9. And let's say we didn't know that this number was 2. So this number here is x. Right. And we want to rearrange this equation to make x the subject. So we want to rearrange this equation to make x the subject. Now that's actually pretty hard to do, okay, but with something called logarithms we can do that. Right, all you have to do is rewrite it. So with logarithms, what happens is you have, instead of y equals a to the power of x, you have log base a of y equals x. Log base a of y equals x. And notice how x is now the subject of our equation. So now we can rewrite 9 equals 3 to the power of x as log base 3 of 9 equals x. Okay, so x is now the subject of our equation. And so how is that useful? Well, because x is now the subject, we can now type this in the calculator to find out what x is. So we can now find the unknown variable when x is in the power position. Okay, but that's pretty difficult because on the calculator the log button is actually to the base 10. So on the calculator oops, on the calculator you only have log base 10. Okay, so when you see the log button on your calculator, it actually means log base 10. Okay, so if we're gonna do that, if we're gonna use the log button to solve some questions, we can only solve problems where the base is 10. So we're gonna try that first, just to get you familiar with the concept. So if I asked you a question, if I said 10 to the power of x, which we don't know, is 1,000. Okay, so what's x? Well, without even using the calculator, you know that 10 times 10 times 10 is 1,000. So therefore x must equal 3. Alright, so that's pretty simple, but we want to try and use our log button to solve that. So rewriting this equation using the log format, if you remember the rule I just taught you before, we can rewrite this as log base 10 of 1,000 equals x. Okay, so if you type in the calculator, so now I want you to type in the calculator log of 1,000 and finish the bracket. Now notice how on the calculator it just says log, but it actually means log base 10. So if you type that in the calculator, you get 3. Okay, so x equals 3. So now if I asked you 10 to the power of x equals 2,350. Okay, what's x? So using the log button on the calculator, you can then figure out that log base 10 of 2,350 equals x. So we're going to type that in the calculator. X equals log 2350, and the answer is 3.37. Okay, so now we can solve any indicial equation where the base is 10. 10 to the power of x equals something. We can find out what x equals. But how will we do something like this one, where we have 3 to the power of x equals 950? Right, how do we know what x is? Right, because we don't have log base 3 on the calculator. We don't have log base 3 on the calculator. So how can we figure out what that one is? So before we can do this, we now need to introduce you to some rules with logarithms. So just before we move on to the next section, let's just quickly test you on some basics that we learned in the last couple of minutes. So if we have rewrite the following rewrite the following in log notation. In log form. So let's do 5 to the power of 3 equals 125. 2 to the power of negative 3 equals 1 over 8. Okay, and rewrite the following in index form. So we have log base 3 of 9 equals 2, and log base 4 of 16 equals 2, and the third one is solve for x. 10 to the power of x equals 4,000, and the second one, let's do 5 to the power, oh no, we can only do base 10, so 10 to the power of x equals 9,000. Okay, so I'll give you a minute to do that, and then we'll come back and do the answers. Okay, so the first one is just log base 5 of 125 equals 3. We have log base 2 of 1 over 8 equals negative 3. Here we have 3 to the power of 2 is 9, 4 to the power of 2 is 16, 10 to the power of something is 4,000. So in the calculator, actually let's write out the logs first. So log base 10 of 4,000 equals x. So using our calculator, log of 4,000 is 3.60, 1 dp, 1 decimal place, and log base 10 of 9,000 is what is that? Log 9,000, 3.95, 3.95, so that's 4.0, 1 dp. Okay, so if you did these successfully, then you can continue with the rest of the lesson. Okay, so here are some log rules that you need to learn in order to solve some more log problems. And the first log rule is when you have the logarithms of the same base, add adding on to each other. So log base a of m plus log base a of n. Now that is the same thing as log base a of m times n. Okay, and you also have log of quotient. So log base a of m minus log base a of n is log base a of m divided by n, and log base a of m to the power of n is the same as n times log base a of m. This is actually the most important one. Okay, what it's saying is that when you have a log of a number with a power inside, so the base numeral contains a power, you can actually move this base numeral to the front. Okay, so that's what's happened there. N is now at the front. So that's actually a very important rule. And another rule is log base a of a is 1. And this rule is pretty simple because if you think about it, a to the power of a is 1. Right? Anything to the power of itself is 1. Actually, I think I just said that wrong. Anything to the power of 1 is equal to itself. Okay, and the last one is log base a of 1 equals 0. And that comes from the index law. A to the power of 0 is 1. Anything to the power of 0 is 1. So these are the log rules that you need to know in order to solve all the log problems. Okay, so let's go to the next slide where we utilize some of these laws to solve the problems. So let's do the first one. Log base 10 of 5 plus log base 10 of 6 equals. Okay, so if you remember the first rule we just did before, that equals log base 10 of 5 times 6, so that equals log base 10 of 30. Okay, now let's do a minus. Let's do a minus one. If we have something like rule. Actually, let's go back and name our log rules. So I'm gonna call this log rule number 1, 2, 3, 4, 5. Okay, so using log rule number 3, we can solve that problem I just made up, which is now gone because I did something stupid. So using log rule number 3, we can solve this problem where we have log. Let's just do one where we solve that single one. So log 3 log base 2 of 3. So that equals log base 2 of 3 to the power of 3, which is log base 2 of 27. Okay, so if we had something like 3 log base 2 of 3 minus 2 log base 2 of 4, so that becomes log base 2 of 27 minus log base 2 of 4 to the power of 2 is 16, and that becomes log base 2. We got 27 over 16, and 27 over 16, you can't really simplify that into a whole number, but you can write it as a decimal, 1.6875 if you wish. Okay, so that's using the third log rule. These can become pretty complicated when the question requires you to use your brain a little bit, combining log rules and laws for fractions. So if we have something like log, let's say base 4 of let's say 9, right, over log base 4 of 27. Okay, how do we simplify that? Well, back in the log rules, if you go back to have a look at the log rules, oops, can't actually go back now, but you can go back and have a look at the log rules, and you can see that none of them actually simplifies or has anything to do with a fraction where you got logs on both top and the bottom. So what you can do is just think in your head, well, if we had the same thing on both the top and the bottom, then we can simplify it. So is there a way for us to make these two logs exactly the same? Well, if you convert both numbers in the base numeral into base 3, oops, 9 is the same as 3 to the power of 2, and 27 is the same as 3 to the power of 3. And now we can use log rule number 3 to bring the 2 to the front and bring the 3 to the front. So now we have 2 times log base 4 of 3 over 3 times log base 4 of 3. And now we have both the top and the bottom. These two terms are exactly the same. These two terms are exactly the same. So the same number divided by itself is just 1. So now we're left with 2 over 3. So I'll just give you a couple of questions to practice. Is 5 of x minus 1 plus log base 5 of x plus 2. Okay, so I'll give you a minute to do these, and then when you're done, come back and check the answers. Okay, so we got log base 3 of 8 plus log base 3 of 7. That's log base 3 of 8 times 7 is 56. Log base 4 of 25 divided by 5 is 5. Now we have log base 4 of 2 to the power of 2 is 4. So all of this is 4 plus 3 log base 4 of 1. Oops. So we got log base 4 of 1 to the power of 3. 1 to the power of 3 is just 1, so forget the 3. So that equals log base 4 of 4. Because 4 times 1 is just 4. Okay, the last one, we got a bit of an algebra question there. So let's simplify the first part. We got log base 5 of x plus 1 to the power x minus 1 to the power of 2 plus log base 5 of x plus 2. And then that will simplify down to log base 5 of x minus 1 squared times x plus 2. And we're not going to simplify that, we're not going to expand it or anything, as long as you understand how to apply the log rules, that should be fine. Okay, so continuing with our original problem, and that's going to be the last section of our log tutorial. If we have a base of, let's say, 7 to the power of x equals 500, how do we find what x is? Well, on the calculator we have log base 10, and the first step is we're going to log base 10 both sides. So then it becomes log base 10 of 7 to the power of x is log base 10 of 500. Okay, now we're going to move x to the front. So we're moving x to the front, and then this becomes x times log base 10 of 7 equals log base 10 of 500. Now if you remember how to rearrange equations, we can now move the log base 10 of 7 to the other side of the equal sign, and this will make it x equals log base 10 of 500 divided by log base 10 of 7. And because we can type this in the calculator, this will then solve the problem. So log 500 divided by log 7. Oops, let's just go back one bit. Finish the bracket, and then divided by log 7. So be careful when you type this in. Equals 3.19. Okay, and try to see that it works. So if we put 7 to the power of 3.19, check that it's working. 7 to the power of 3.19, 7 to the power of 3.19, and you get 496.43. And the reason why it's not exactly 500 is because we rounded it off at 2 dp. Okay, otherwise it'll be exactly the same, so make sure you write 2 dp there. Okay, so this actually I'll just give you guys some practice questions. 3 will probably be enough. 5 to the power of x equals 600. Actually 2 will probably be enough. 11 to the power of x is 300. Okay, give you a minute to do them, come back and check the answer. So log, you don't even have to write base 10, right? Because if you just write log, it is assumed that you're talking about base 10. So log 5 to the power of x is log 600. So moving x to the front, x log 5 equals log 600. So x equals log 600 over log 5. Oops. And using the calculator, log 600 over log 5. Oops. That's backspace. 3.97. 3.97. Let's see if that makes sense. So 5 to the power of 3.97. Yep, close enough. And then the same thing happening here. Log. So log both sides. Log 11x equals log 300. X equals log 300 over log 11. Actually, I jumped a step here. I really should write x log 11 equals log 300. Alright, so make sure you show all the working out, especially in the exam. You don't wanna just skip to the answer, because then you'll lose marks. So log 300 divided by log 11, and that's 2.37. So x equals 2.37. 2dp. Okay, so that concludes our log tutorial. Hope this helped you a little bit with logs, and see you next time.